Hello, AP Chemistry students. This is Mrs. Altman. We are on the first video of the year, Thermochemistry Part 1. This is Chapter 6 of your textbook. Those of you who took Chemistry 10HH during the 2017-2018 school year have actually already learned this material, but those of you who took it in the 18-19 school year have not. We have two sets of objectives pretty much for every video this year. You'll see the objectives look a little bit different. So as far as skills, you're going to be working on calculations with work and internal energy. And then we have a number of vocabulary terms that relate to energy, heat, work, and all these sorts of things that you may or may not have seen in past science classes. Pause here. So you may have already heard about this since we did talk about it a little bit last year. Energy is the capacity to do work, work being force over a distance, or to produce heat. And we all know the law of conservation of mass. The law of conservation of energy is really just another facet of the law of conservation of mass. So energy is also conserved, so meaning that energy cannot be created or destroyed, but can be converted from one form to another. That is also the first law of thermodynamics. Pause here. All right, so we're going to be talking about two types of energy. The first is potential energy. So that is the energy that a particle has due to its position. So these typically arise from what's called Coulombic forces. So those are forces between charged particles. Whereas kinetic energy, we talked about this with gas laws last year, that is the energy a particle has due to its motion. And then if you didn't already know it, I'm going to give you the equation for it. We're not going to really be doing like calculations with it. It's more for your own general knowledge, conceptual knowledge. The kinetic energy is equal to 1/2 mv squared. So it's directly related to mass and directly related to squared velocity. Pause here. Right, so we're going to talk a lot about heat in this chapter. Heat is the quantity of energy transferred from one object to another. Really, really important thing is that heat is not the same thing as temperature. Heat is an overall quantity, meaning if you have more of something, you have more heat, whereas temperature is an average quantity. So no matter how much of something you have, if the average kinetic energy is the same, they'll be at the same temperature. And then work, which is another way that we could transfer energy, is force acting over a distance. So if you were to take a physics class, you would see a lot of examples with it. But in chemistry, it's going to come from the expansion or compression of a gas. And both of these are going to be measured in joules. We could abbreviate that to J. Sometimes you'll see it as kilojoules as well. Pause here. So these do not need to be memorized. These are just equations you will need to work with. We're not actually going to be doing a whole ton of calculations with this as we get to our AP practice. This is more for your own general conceptual knowledge. Pause here. All right, so let's get to this. All right, so the question says, calculate the change in internal energy when 4502 kilojoules of heat are released. So since it is released, it's going to be negative 4502 joules. And then we know that pressure is 1.00 atm. And we know that our V initial is 5.0 liters. And our V final is 7.5 liters. So I'm going to calculate work. Notice that this is in liters atmospheres. That means we need to convert it to joules. So I converted it, I got negative 250 joules, so that I can just go back to this equation. So negative 4750 joules, so a lot of energy is released. That tends to be a pretty favorable reaction. Pause here. So I talked about this a little bit in the example, but I just want to make sure that you have it in your notes in case this is not immediately obvious to you. So Q is positive when energy is absorbed. And when I say energy, I really am referring to heat energy here because we're talking about Q. So it would be an endothermic reaction. And it is negative when it is released. Sometimes it will not mathematically work out that way, and you will need to manually change the sign. W is positive when work is done on the system by the surroundings. So compression, the outside air compresses whatever system we have, and negative when work is done by the system or expansion. And then these are the additional practice problems. We'll have some time in class to work on them, but if we don't have a time in class, they will be due at a date that I post on Google Classroom. Thank you so much for watching, and have a good night.